Okay, so I finished marking all your quizzes, some pretty nice marks. That was easy marking. One student got 150%, which was quite nice. So the extra marks, they'll be carried over to next week. There were about 4 with 100, 1 with 90. You got 90. You made a small mistake. Yeah, you got 90. That's fine. Then there was 85, 80, couple 70s. So pretty good marks. Have you looked at your marks yet? We haven't looked. Okay. Please have a look on SMS. Just check your Student Central. Just check your marks there. Any issues? Come and see me in my office. And then the one with 150. I didn't see where you are. That extra will be carried over for next week. Okay, so we're going to take a little break from integration for a couple of weeks. We're going to be. Someone say, "Thank God." I heard that. Okay. No worries. Integration will come back later. It won't be gone for too long. Okay, so these next few chapters, we won't be looking at any integration. So polar coordinates, conic sections, sequences, and series. There won't be any integration there. And then later, towards the end of the year, we'll see integration again. Okay, but you have a break for a little bit. Okay, so today we're going to be looking at polar coordinates. Okay, you might have seen a bit of polar coordinates in physics with circular motion and so on. But we're going to be looking at it more on the mathematical side. Okay, so as a coordinate system. Okay, so first a recap of what a coordinate system is, and then we'll look at the similarities and differences between Cartesian coordinates. You're very familiar with that one, and then polar coordinates. Okay, next year, you'll be looking at other coordinate systems, and when you do your double and triple integrals, you'll be doing that over other types of coordinate systems. Okay, so double integrals over Cartesian, double integrals over polar, and so on. Okay, so it's very important that you understand these coordinate systems and how they work. Okay, quick recap. What is a coordinate system? So coordinate systems are a way to label points in some space. Right, so you're very familiar with the Cartesian system. So in this 3D space, you can pick a point and it will be some x, y, z. If you're looking at a 2D system, you pick a point, that will be some x, y. Okay, so you're familiar with the idea of labeling points in Cartesian coordinates. Okay, so different coordinate systems. Okay, will result in different labels for the same point. Right, so you can have some points in space. If you use one coordinate system, you label it one way. If you use a different coordinate system, you're going to label it a different way, right? So same point, two different labels. So let's have a look at an example of this. So let's say I'm standing over here and I set up a Cartesian coordinate system. Yeah, so you know what that looks like. That's just a regular grid, like so. So let's say in blue over there, I'm going to choose that to be my origin point. So that's going to be my origin point there for the coordinate system. Going up, that will be y values. Going left and right, those will be x values. So this point P over here, so that green point P, in my coordinate system, that's going to be 2 across, 2 up. So I give that the label 2, 2. Okay. Now, let's say you're standing over here. Okay, you've got your origin point over there. So that's your origin there. And you're also going to label the same points. So let's call it P. So you're going to label the same point. So the point hasn't changed, but now it's going to be minus 2, right? Because it's going the other way. So here you would label it as minus 2, 2. Okay, so it's exactly the same point. My coordinate system, I call it 2, 2. Your coordinate system, you call it minus 2, 2. Exactly the same point, two different labels. Okay, now that is in terms of Cartesian, but there's nothing to say that we have to choose the same coordinate system, right? I could choose one, you could choose another. Again, you're going to have two different labels. So let's have a look at what a polar coordinate system will look like. Okay, so we know Cartesian. Okay, so I'll just redraw that grid. Okay, you know what that means. So we have vertical lines, horizontal lines. You pick some origin point. So that will be x equals 0, x equals 1, and so on. And then going vertically, that will be y equals 0, y equals 1, and so on, right? So vertical y values, horizontal x values, and you can label any points as x, y. This is for Cartesian. Okay. For polar coordinates, again, you might be familiar, but if you aren't, we'll go through it again, is a different way of setting up this grid. So it won't be a rectangular grid with vertical lines and horizontal lines. Instead, we do something a little bit different. So we pick an origin point in the middle, and what we do is we draw concentric circles coming from that origin point, okay, with different radii. So we're going to draw a circle with radius 1. We're going to draw a circle with radius 2, and so on. These go outwards. Okay, we've got another circle, radius 3. Okay, so those circles are going to go outwards, and that's going to be the first part of the coordinates. What is the radius from the center point? Okay, so that's the first part. And then the second part is we choose some line, okay, preferably the horizontal, that's what we typically use. That is going to measure a 0 angle. Okay, right, typically we use that line. Okay, so we call that the 0 angle line. Then, going around the circle counterclockwise, we increase the angle. Right, that's the generally accepted way of doing it, right? There might be other ways, but that's the way we're going to stick to. So we've got this as our 0 angle, right? We've got this as our pi over 4 angle, okay? And it's going to go around like that. So this will be 0, pi over 4, up vertical. So that is 90 degrees from that horizontal line. So this angle is pi over 2. And you can fill in all the lines going around. So here, this will be pi. Going down, this will be 3 pi over 2. And so on, right? You can fill in all the lines in between. Now, any points in this system will then be labeled by the radius from the center. So on which circle are you on? So which radius do you have? And secondly, what is your angle from that horizontal? So here in polar coordinates, we use r and theta. So again, the first part is your distance from the center, and the second part is the angle that it makes with that horizontal line. For example, this green point over here, it is on the second circle. It has R2, and it's on that line with angle pi over 4. So that coordinate is given by 2 comma pi over 4. The radius is 2, the angle is pi over 4. So this green dot is at 2 pi over 4. Okay, so we use those 2 bits of information to say where that point is. Okay, we won't be doing too much of plotting points. I'll save that for the tutorial. So the first part of the tutorial, if you've had a look already, is plotting these points. So given an r value, given a theta value, where is that point going to be? Okay, so please go through the tutorial for that. Okay, and then just an important note. The radius r can't be negative. Okay, very, very important. This radius r is a distance. Yes? You can't see the red. Okay, let's put in a different color. Is that better? Okay. So I'll rewrite that. So the radius r is not negative. Okay, you cannot have a negative distance. It means nothing. Okay, so the radius is always positive. Now, if you have a point with a negative radius, what that means is you take the positive of that radius and you add pi to the angle. Okay, so that's just the rule that we use. So if r is less than 0 for whatever reason, whatever problem you come across, if you end up with r being less than 0, what you need to do is take the positive of that. So you take the positive r and add pi to the angle. That's the rule that we use for having a negative radius. Okay, so then your angle becomes whatever it was plus pi. Okay, now you know adding pi, that's a 180 flip. So you can think of this as whenever the radius is negative, you do a 180 flip on that. So we'll do an example. Okay, so we have our coordinate system. So let's say we're trying to plot the point minus 2 pi over 4. So whatever reason, we ended up with this point that we needed to plot. We see that the radius is negative. So if the radius was positive, we would be somewhere there. Okay, radius 2 angle pi over 4. But since the radius is negative, we need to flip over 180. And the point is now there. Okay, it's a flip across. It's a 180 degree flip. So we take the radius to be positive. So 2 pi over 4, that would be up there in that like first quadrant. Now, since the radius is negative, you do a 180 flip and the point goes to the third quadrant. Okay, does everyone understand that rule? Okay, again, if the radius is negative, you take whatever the positive is, and then you add pi to the angle, or you add 180. Okay, however you want to think about it. Okay, transforming between coordinate systems. Okay, you might have seen this quite a bit in physics with circular motion. If you haven't, you'll certainly see it next year. Okay, so given a problem in one coordinate system, you need to be able to convert it to a problem in another coordinate system. Okay, so if you haven't done it in physics, you'll definitely see it in the maths next year. Okay, so we'll look at the case of Cartesian to polar, polar to Cartesian. However, this does work in general. So next year, when you do all those other coordinate systems, the same idea applies. Okay, but for this year, we're only looking at these two. Okay, so we want to go from polar to Cartesian by some method, or we want to go from Cartesian to polar. We want to go back and forth between them. Okay, so how do we go about doing that? Okay, so let's start off with Cartesian. Okay, we're more familiar with that. So we're going to set up our Cartesian system. So we know how that works, x-axis, y-axis, and we've got some point P. P. Okay, so what we want to do is write down that label for P two different ways. We want to write it using Cartesian, then we're going to write it using polar, and we're going to see how we go between them. So firstly, for Cartesian, what do we need? We need the x distance and the y distance. So this distance here will be x. From the origin to P, going horizontally, that distance is x. From the origin to P vertically, that distance is y. Okay, so horizontal distance x, vertical distance y, that gives us our xy. Okay, now that's in Cartesian, we know how to do that. What about polar? Let's go back to how we define polar coordinates over here. So for polar coordinates, we have an origin, we have a horizontal axis, and then we have that radius going out to the point, right? Like that green dot over there, there was a radius of 2, an angle of pi over 4. We're going to do exactly the same thing here. Okay, so now we imagine polar coordinates. So again, we start from the origin. We've got some radius. From the origin to the point P, that's the radius. R. Okay. So again, Cartesian, that's in the white, polar, that's in the pink. Now we also need the angle from the horizontal going counterclockwise. So from the horizontal to that radial line, that angle is going to be theta. Yeah. Does everyone see what we did there? Okay, so we looked at the point P in terms of Cartesian x and y, and now we looked at the point P in terms of r and theta for polar. But now, if you look a bit closely, we have a right angle triangle. We've got 3 sides, we've got an angle, we can use some trig. Okay, so what can we do? Let's start off with, given the polar parts, how do we find the Cartesian parts? So number 1, given the polar coordinates, so that will be r and theta. So that's given to us. We know what r and theta are. What are x and y? What is the Cartesian coordinates? xy. Okay, so we start with polar. That's given to us. We want Cartesian. So given this information of r and theta, what is x going to be? We know r, we know theta. That's all that's given to us. What is x? R cos theta. Good. Okay. So we've got that first part. We've got x is r cos theta. What about the y part? R sin theta. Okay, good. So given r and theta, we can calculate x and y. That will be y. Okay. Any questions? Easy enough. Okay, number 2, how do we go the other way? So given the Cartesian coordinates, xy, so now we go the other way. I give you x and y. The question is, what is r and theta? Okay, so let's do r. Okay, so we want to work out what r is. Okay, so again, we go back to our triangle. We're given 2 sides. The third one there is missing. How do we find r? Pythagoras. Good. So that's going to be root x squared plus y squared. Okay, again, we're given x and y. We want to know r. It's just Pythagoras. Okay, again, we go back up to the triangle. We're given x and y. Again, we're not given anything else. And now the question is, what is theta? So arctan of y over x. Good. Okay, easy stuff. Okay, that's how we go back and forth between the two. So just to summarize, if I give you r and theta, and the question is what is Cartesian, we use this equation set from number 1. So r and theta are given, we can use that to find x and y. And then going the other way, if I give you x and y, and the question is what is r and theta, we can use these equations from number 2. Okay, any questions on going between them? Oh, good. Okay, so the second part of the tutorial, that will cover going between the two. Okay, so you'll see the first part will give you some polar coordinates, and it'll say what is the Cartesian, and then the second part will be here's the Cartesian, what's the polar. Okay, and you use these equations to go back and forth between them. All right, any questions on this before we move on? All good. Okay, so that's going back and forth between points. The second part is going back and forth between graphs. So we can have a graph in Cartesian coordinates, y equals f of x. We can have a graph in polar coordinates. Now we're going to have r as a function of theta instead of y as a function of x. Okay, so graphs in polar and Cartesian coordinates. Okay. Again, in Cartesian, we have the graph y as a function of x. In polar, we now have the graph as r as a function of theta. Okay, let's have a look at the first example. So for these first two examples, we have the graph in Cartesian coordinates, so that's what's given to us. Now we want to convert everything over into polar. So instead of using the Cartesian axes and all the x and y, we're going to use r and theta. Okay, so number 1, we have y equals 1 over x. Okay, we know what this looks like in Cartesian form. We can sketch it in Cartesian form. Now we want to do this in polar coordinates. So we are given Cartesian. We want polar. So we go back here. Which one do we use? Who says the second one? Don't be shy. You're not being marked on it. I just want to see a few. Okay, who says the first one? Who's failing the next quiz because they don't know? Okay, one person's honest. Okay, it's going to be the first one. Okay, so we have x is r cos theta and y is r sin theta. Okay, so why do we use this first one? Well, we're given x and y. We want the answer to finally be in terms of r and theta. So we make the substitution that gives us r and theta. So we use this one. Okay, so y, that's going to be r sin theta, and x, that's going to be r cos theta. You see, now it's in polar form, which is what we wanted. Okay, doing it the other way, you're going to be going around in circles. Okay, so we've got this form, but what we want is r as a function of theta. So on the first line, we have y as a function of x. Now we want r as a function of theta. So there's a little bit of work we have to do, not too much. Let's take that denominator from the right-hand side over. So we're going to have r squared sine theta cos theta is equal to 1. Okay, so now we got r squared over there. We want r, so we want to keep that there. So sine theta cos theta, let's take that over. Yep. So we end up with that. Now we don't want r squared, we just want r by itself. So let's take the root. Yeah, here we have r is a function of theta. So we started off with y is a function of x. We want to go all into polar. So that same graph in polar now looks like this. So we have r as a function of theta. Okay. Let's just see if this Wi-Fi is working. You're familiar with Desmos now. You should have been using it for like a year and a half. So let's go into Desmos. You can all see that. Okay, so you're familiar with this form. Okay, you should be familiar with all this Cartesian stuff going on. Just make a note of this. In the top right, you go here to graph settings, and you click this one over here, the second bit. So this first one over here, this grid, that means Cartesian. The second option here with the concentric circles, that means polar. So you click that, and now everything goes to polar. Okay, so now that it's in polar, we can put our polar function, and it will sketch it. So let's put r of theta is equal to, we just copy that. Okay, so that's going to be equal to square root 1 over sine theta cos theta. That's right. Remember your brackets. Okay, and we get the shape. Now the shape is very familiar to you. That's exactly what we started with, the 1 over x. So the 1 over x, right, it has to have the same shape. We're just changing coordinates. We're not changing the graph. So in Cartesian, it was 1 over x, and we know it has this shape. In polar, it now looks like this, right? It looks like it's changed, but if you plot it, it's exactly the same. And it must be the same. We haven't changed anything about the graph. Okay. Right, it just looks different because of this background changing to polar now. Okay, but the graph is exactly the same as before. So please, in the tutorial, when you have to sketch the polar functions, try it out first, and then go on Desmos, and then try plot it like this. Okay, and again, you put the little button here, this first one, and then you click the second option here for polar coordinates. And you can go back and forth between them. Right, doesn't change the graph, of course, it can't. But here, this is the Cartesian, here's the polar. Right. Any questions on using the Desmos? Okay, please make use of that. And make sure, another thing, make sure it's on radians. Okay, this bottom part. You change it to degrees, everything goes wrong. Okay, so please make sure this is still on radians when you're using it. Okay, so that's example 1. Let's have a look at example 2. So we're given y equals 3x plus 1. So straight line, we know what this looks like. Now we want to change from Cartesian system to polar system. And again, we're going to use these equations here on the right. So wherever you see an x, you put the r cos theta. Wherever you see a y, you put the r sin theta. And let's see what we get. So y, that's going to be r sin theta. X, that's going to be r cos theta. Everything else stays the same. And now what's the goal? The goal is to find r as a function of theta. So we solve for r. So r sin theta minus 3 r cos theta, that's 1. That can stay there. We've got r and r. We can factor that out. Sin theta minus 3 cos theta is 1. Finally, dividing through by all of that there, we're going to have r of theta is 1 over sin theta minus 3 cos theta. Now, this function looks very complicated. Okay, you've got 2 trig functions in the denominator. Very complicated looking function. Let's see what it looks like. So we go back here. Let's get rid of that. So we're going to have r of theta is equal to 1 over, and then all of this denominator. So sin theta minus 3 cos theta. And of course, we get the straight line, right? That's what we started with. Okay. And if I change this to, back to Cartesian, it's exactly the straight line you expected, right? 3x plus 1. Okay, but it just has this funny form here because we're not working in Cartesian, we're working in polar. Okay, but again, the graph is exactly the same. Right, any questions on these two? Yes? Because sometimes it's simpler in polar. So we'll see. These two examples are not the best because you know what it looks like in Cartesian. So it's nice and friendly looking. Later on, we'll see some problems are better worked out in polar. Okay. And we'll see these next two. It's better in polar. Okay. But good question though. Any other questions for these two? No. Okay. So this was going from Cartesian to polar. Now we go the other way. So this is example 3. R equals 2. Yeah. So what is this in Cartesian? Right? This is a function of theta. R of theta is 2. Yeah, it's a constant function. Now we want to see what does this look like in Cartesian coordinates, and then that will answer your question. Yeah. So what do? We do the substitution. Now instead of substituting this one like we had before, we now substitute the other one because we're going backwards. Okay, so R is going to be root of x squared plus y squared, and that will be 2. Okay, and theta, that was arctan y over x. Okay, now we can square both sides. X squared plus y squared is 2 squared. Okay, what is that Cartesian form? What is that going to be? A circle. What's the radius? 4. 2. Who's saying 4? Okay, minus marks. Okay, it's a circle with radius 2. Now this looks very complicated. You know, obviously you know what a circle equation is, but this looks pretty complicated in Cartesian. X squared plus y squared equals 4. Okay, we know it's a circle of radius 2. What does that first equation tell us? The radius is 2. Much simpler. Okay, so in polar, what would we do? Okay, we would set up our thing here. And all we do is R is 2. So we just draw in that circle of radius 2 line. Okay, so here R is 2. Okay, so in polar coordinates, if we have the equation R of theta equals some constant, oh, that's just a circle. Okay. Any questions on this one? So we see in this case, the Cartesian form is a bit complicated, but the polar form is as simple as it gets, R equals 2. Okay, and then number 4, we have R is equal to 2 cos theta. Okay, again, it's some function of theta, so R of theta equals 2 cos theta. What we want to do is figure out what is this going to look like in the Cartesian form. So we make the same substitution as before. Here we can do a little bit of a trick just to make things easier. On the left, we have R. What we want is something more like R squared. That would be easier to work with. So let's multiply both sides by R. So R squared to R cos theta. So on the left-hand side, R squared, we know that will be x squared plus y squared. That's easier to work with. On the right-hand side, we now have R cos theta. We know that's x. Okay, so it's a little bit easier to work like this. So we multiply both sides by R. The left-hand side becomes easier to work with, and the right-hand side becomes R cos theta, which is just x. Okay, little trick just to make things a bit easier for you. Now, R squared, we know what that is. That's x squared plus y squared. R cos theta, that's just x. Okay, now we can simplify this a little bit more. So we have x squared minus 2x plus y squared is equal to 0. X squared minus 2x, we can complete the square. Please go over your completing the square. You will need to know it. X minus 1 squared minus 1 plus y squared is 0. So here we have x minus 1 squared plus y squared is 1 squared. Okay. So what is this now? This is also a circle. It has radius 1 from the right hand side, but it is shifted to the right by 1, right? X minus 1. So it's a circle of radius 1 shifted by 1. That's what we expect. So let's plot this in Cartesian polar form and see if we get that. Okay, so we go back here, get rid of that. So this will be r of theta equals 2, and we had cos theta. Right, that's exactly what we get. Okay, so we can zoom in a bit just to see the 1 there. So that's exactly what we expected. It's a circle of radius 1. See, the diameter there is 2, so the radius is 1. And the center of the circle is at 1, 0. That's what we expected. Okay. So this over here, this is a circle of radius 1. Okay, with center at x equals 1, y equals 0. Okay, so it's been moved over. Okay, and then for a little bit of homework. What is this going to be? So now we have 2 sine theta. Any guesses? Sorry? Not the left. Shifted up, yeah. Okay. You can tell just by quickly looking at it, we've got sine theta. Sine theta goes with y. So shifted up. Yeah. Okay. For homework, convert this into Cartesian, and then you'll see the correct shifting there. Right. Any questions for these two? Yep. Like this. Yes. Yeah. Yeah. So whatever it is, you'll leave it like that. So if it's a circle, please write it in that circle form. So it's got the radius and the center. Okay. Please leave it like that. Right. Any other questions? No. Okay. So we'll just start with the next bit, and then we'll save the rest for the double. Okay. Sketching curves in polar coordinates. Okay. So when I say sketching curves in polar coordinates, it means you're given something like this. Okay. Some function of theta. So r of theta is 2 cos theta, or r of theta is 2 sine theta, whatever it might be. And only with that knowledge, you then need to plot it in polar coordinates. Okay. You could try convert it to Cartesian, but then you're wasting time. It might be a bit too complicated with that. Okay, but we're going to start off with something very simple. So r is 2 cos theta. Okay, so before we saw that this was a circle shifted to the right by 1. Now we're going to go through the whole process of trying to sketch it, and we should end up with the same thing. Okay, so how are we going to go about doing this? So let's see what this looks like just in terms of r as a function of theta. Okay, so it's a little bit of side working just to see what this looks like. And then from this, we can then plot it a little bit easier. Now you don't have to use this method. You can use whatever method you like. This is just one of them. Okay, so what does this look like? It's going to look something like this. So it'll be 2 minus 2, pi over 2, pi, 2 pi. Right, you know your special angles along there. Okay. So what we do is we set up our polar coordinate system. So for curve sketching that you did last year, you did your Cartesian system and then you did your sketching. Now we're going to use our polar system and then do the sketching. So it's going to look something like this. Okay, so we got our angles. You can put in more angles if you need. You can put less angles if you need. But this will do for this example. Okay, so we've got 0, pi over 4, pi over 2, and all the way around. Okay, and then what about the circles? So here we've got 2. Okay, so it's bounded between minus 2 and 2. So let's just draw a couple. We don't have to do too many. So let's say there, there, there. Okay, something like that. So at the end, you'll end up with this spiderweb kind of shape. Okay, so the axes are all set up now. So we have radius 1, radius 2, radius 3 going outwards, and we have our angle 0, pi over 4, pi over 2, right, all the way around. Okay, so how do we plot this? Well, let's start at the beginning. What happens when the angle is 0? We see where the point is. What happens when the angle is pi over 4? We're going to put a point there. What happens when the angle is pi over 2? Put a point, and so on. You get a whole bunch of points going around, and then we connect the dots. Okay, that's the rough idea. Okay, so let's fill it in. When the angle is 0, we see that the radius is 2. So now we plot that point, and it's a polar point. R equals 2, theta is 0. So that will be over there. Yeah. So this is why that polar coordinate plotting is important. Okay, for this bit. Let's go to some other angle. Let's say pi over 4. That's that slanted line over there. So when the angle is pi over 4, what's the radius going to be? You have your calculators. Use them. Okay, so we have r of theta, and we're looking at pi over 4. What will it be? Root 2. Good. Okay, so that will be somewhere there. Well, it's less than 2, so somewhere. Okay, at pi over 2, what's the radius? So you shouldn't need your calculators for that one. I'll put it in for you. Yeah, there's a 2 in front. Okay. Okay, when the angle is pi over 2, the radius is 0. So we didn't go anywhere from the origin, so we're back here. Okay. Now, you can fill in all the in-between angles if you need, but this will give you a rough idea of what it looks like. What about this angle over here? What angle is that going to be? Okay, this one's pi over 4, and we go all the way around to here. What's that going to be? Come, you must know your angles going around a circle. Okay, 0, pi over 4, pi over 2. You're going up in pi over 4s, right? In this diagram. Okay, what's that last one? Second to last one? What is it? Hmm? 3 over 2 pi. You sure? Okay, this line over here in the bottom quadrant. What is this angle? So 0, pi over 4, pi over 2, loop around. What is it? Okay, add up the lines. Pi over 4, pi over 2. Next one. Hmm? You sound unsure. Yes. I want the answer, not another question. Okay, there's 1 pi over 4, there's 2 pi over 4, 3 pi over 4, 4 pi over 4, count with me, 5 pi over 4, 6 pi over 4, 7 pi over 4, thank you. Gosh, we must go back to counting. Okay, 7 pi over 4, what's the radius? Root 2, yeah, it'll be root 2. So along this line, it'll be somewhere over there. Yeah. Now, again, this is a very rough picture. When you do it at home, you'll fill in more angles than I did, but you end up with something like this. Yeah. You end up with that circle. With that inside point there at 1, that will be the center. Okay. As expected, right? This was supposed to be a circle of radius 1 shifted to the right. So when you connect up all the dots, that's what we get there. Okay. Any questions on this? Okay, so again, the rough idea, you divide it up into some number of angles. You might need more, you might need less. Okay. Then you go 0 and you ask yourself, what's the radius? And you put the point. Then you go to pi over 6, for example. You say, where's the point? And then pi over 4, maybe pi over 3, pi over 2, all the way around. Once you get back to 2 pi, you're going to have a whole bunch of points going around, and then you connect the dots. Okay, that will give you the full picture. So I'll give you one for homework, but then we'll go through the rest in the double period. So homework. So r of theta is sine theta plus 1. Okay. Again, 0 to 2 pi, you go all the way around, and then you connect the dots. So this problem, you try it out for homework, and then during the double, we will then start with this problem. All right. Any questions about the homework? You're good. Okay, and please go over your angles going around. Okay, very important.